Okay, moving on to section 1.5, let's talk about modifying the operation. One of the important features of a PLC is the ease with which the program can be changed. The original hardwired process control circuit modified. You have the ability to know and determine what to change that what change is required that the manual push button control be permitted to operate at any pressure, but not unless the specified temperature settings has been reached. So we have these kind of possibilities which you can be doing. There's no rewiring. That's a powerful thing. If a relay system were used, it would require some rewiring of the circuit. If a PLC system were used, no rewiring would be necessary. The inputs and outputs are still the same. All that is required is to change the PLC ladder logic program. And that's what we've been showing here in the bottom as we talk about these various things as we move forward here. Well, let's now talk about PLCs versus implementing things with computers. The architecture of PLC is basically the same as that of a personal computer. So you can keep that in mind. It definitely is a computational environment. But unlike PCs, unlike PCs, the PLC is designed to operate in the industrial environment. So it's more tailored for that type of application. Unlike the personal computer, the PLC is programmed in relay ladder logic or other easily learned languages. We're talking about this first one, the ladder logic, but we'll get a chance to think about some other things as we move forward. The PLC comes with its program language built into the memory and no permanently attached keyboard, CD drive, or monitor. Those aren't the necessary things for this type of a computer, this type of computing controller. So it's not a PC, but it's a dedicated machine for industrial use. Computers are capable of executing several programs simultaneously in any order. On the other hand, PLCs execute a single program in an orderly and sequential fashion from first to last instruction. Thus, we can see there's different drivers for this type of operation. For troubleshooting is simplified by the use of fault indicators and messaging displays. Input and output modules are easily connected and replaced, and modules slide into the rack, and so fairly easy to manipulate. There are a couple programs that the textbook talks about. We're not going to be using those in this class, but it's informative. RS Logic and RS Links. It is used to program and document the process. The ladder logic is the most popular programming language. Instead of these, since this is a fairly short course, I'm going to use some MathWorks products to give you a little bit of an idea of what it's like to do PLC programming. So for PLC HMI software, that is human machine interface, it's a software that allows the user to monitor and control the process. And so you can see like a cartoon layout of things in operation, and you can view it. So you can view a process with a graphical representation of the process on a monitor. Thus, you can determine how the system is running, trend valves, and receive alarm conditions, all very useful information. So what about programmable automatic controllers? Instead of PLC, you have PACs, PACs. It combined PLC ruggedness with PC functionality. The build advantage system. With this, you can build advanced systems incorporating software capabilities such as advanced control, communication, data logging, and signal processing. PA software is typically event-driven. Now, what about PLC size and application? A single-ended application involves one PLC controlling one process. A multitask PLC application involves one PLC controlling several processes. A control management PLC application involves one PLC controlling several others. And so this is where we can start to see that you can have layers of PLC in the way that you're doing your operation. What about the amount of memory? The amount that is required depends on the number of I/O points, the size of the control program, the data collecting requirements, supervisory functions required, and future expansions. So those are things that you want to be mindful of. For the instruction set for a particular PLC lists the different types of instructions supported. And so here we can see the symbol for a graphic, the name that is associated, and what that means in terms of bits. So we're talking about binary, so it's either 1 or 0. And we'll be getting into some of this as we work through it, but this is trying to give you an example of typical PLC instructions and the things that you would be doing for those ladder diagrams. So just to finish up, finally, memory is a part of the PLC controller that stores data, instructions, and the control program. Memory sizes is usually expressed in K. K stands for 1,000, so a value like 1K, 6K, 12K, and so on. The measure kilo, abbreviated K, normally refers to 1,000, like I said. When dealing with a computer or PLC memory, however, 1K means 1022 because the measurement is based on the binary system. Thus, 2 to the 10 is 1024. Depending on memory size, 1K can mean 1024 bits, 1024 bytes, or 1024 words. Bits is one single digit. Bytes is typically 8 or 16 digits, and word is whatever the size of that might be. So maybe a byte is 8 or 16, a word might be 16. And so that's just a quick synopsis for the first chapter. So thank you very much.